Let's go over containers real quick. So the purpose of making containers, often we have to store water. That's one of the main reasons we'd want some sort of container, is not only to store our water, but to purify it. One of the best ways to do that is by boiling the water. It can be really hard to make a method of distillation, but boiling, there are several different methods of primitive containers that will allow you to boil the water within it, either internally or externally heating the water. And we'll talk a little bit about that in just a second. But containers can also be used for storage of food, cooking food, and food preservation for long-term survival. So we really need to distinguish between short-term, long-term survival, because we're starting to get into that now. So right now we're still talking about short-term survival. What do we do immediately? Containers are still important during that time frame. It might be something that you can find to use as a container, and it doesn't have to be something man-made. So let's just talk a little bit about primitive containers. So ground containers, this could be a hole that you dig, and if it's clay, or if you have a clay source, you can line porous soil with clay and make it waterproof, enough to use hot rocks to boil the water. And I've got some videos on how to do that. Maybe you have a rain jacket or something else that is plastic that's not porous that you can use to cover the ground, and then fill that up with water, and the hole itself just provides the shape of the container. That's one method. You might be able to find a large cavity in a rock that you can use hot rocks to heat. So you pour water in it, or it may already have water, drop the hot rocks in, boil it, and sunlight, if the water was already in a divot in a rock, can actually help you, because the UV light can also kill pathogens. I would not rely on that. I would definitely want to boil it with hot rocks. But you're going to lose some water when you use hot rocks or any method of boiling through evaporation. So you may put a liter of water in the container and come out with a half liter, quarter liter. It just depends on how long you had to boil it for. Bamboo or river cane can be used, especially if it's the larger variety of the bamboo. You can actually heat that externally by putting it directly in flame. It does take a while, but it will work. You will only get so many uses out of the bamboo before you completely burn through the green bamboo. But I've used that method before and stuck large segments of bamboo, and they would hold, each would hold about a liter of water, and then I would boil them in that. But it takes a long time to heat that bamboo up, and eventually over time it dries out, starts to crack, starts to burn, and you can't use it several days in a row. You have to go cut more bamboo, but it does take a while. Wooden containers can be made, so you can carve out wooden containers. You can burn those out. A lot of people will burn out the wooden containers, so you're taking some dry wood, soft wood preferably, because it'll burn faster. Your hardwoods are pretty dense, and it takes a long time to burn into those. And they tend to crack more. Like oak cracks really bad. And I've used sycamore, which is it's kind of a soft wood, and it doesn't crack so bad. And so you use dry sycamore and burn into it, or willow. Willow works pretty good. Cottonwood root works really well, and it's easy to carve out. And the reason you would burn something out as opposed to carving it out is you want to save your knife. You don't want to dull your knife having to carve. And even though it takes longer to burn it out, it is a good method to save your knife. Then low earthenware and ceramic. So you have to have a clay source for this to work, and you have to get your mixture just right. Just the right amount of clay with the right amount of sand mixed in. I've done this, but it takes a long time, and this would be more long-term survival in my opinion. Yes, you can do it within 24 hours, but you really need that clay. The greenware, meaning that it hasn't been fired yet, but it's been dried. You want it to be dried at a minimum 24 hours, but the longer you can let it dry, the more likely it is to survive the firing process. But that's got to have the right elements, right? You have to have clay and sand, and that can be problematic if you're in an environment that doesn't have that. You can't rely on that source. Probably the most common one that's used is like wooden containers or ground containers. Those are the two most common primitive containers that are used, because obviously bamboo is specific to a region. Low earthenware is going to be specific to a region with clay. Most riverbeds, most lake beds, as long as you're not in a real rocky area, will have clay sediment along the edges. So it's not that you can't find it, it's just a pain in the butt to make. So ground containers, let's talk a little bit about those. So you're looking for non-porous ground, or at least clay source that you can line the hole with, or a rocky source. And the advantage is it can be used in most situations. Most of the time you're either going to be in a rocky environment, or you're going to be in an environment where you could dig into the soil and hopefully you have something to line it with. And it can be used in conjunction to heat internally with hot rocks. The limitations, the problem is it's not portable. You're going to have to recreate it if you move around, and you may not have those resources in that area. So it's no external heating, so I can't heat up a ground container. And I really wouldn't want to heat up rock externally. Now, obviously you're heating up hot rocks, but you can get away from those. I wouldn't want to be standing near, especially a river rock that may have moisture in it, because they will explode and they put out your eye. So you're also limited to the resources, meaning you want non-porous ground, or at least some sort of non-porous material that you can line the ground with. Alright, so there is the video for how to make a ground container. That's probably the easiest one for the class to make. Bamboo containers. Now, in Texas we have river cane, we also have bamboo, but we don't have the large varieties. If you would try to make a container out of this, it would have to be small. It would allow you to transport your water in multiple bamboo containers. Green bamboo can be heated externally for a limited amount of time. Can be used, if you have the larger variety, you can use hot rocks and drop them in, or you can split them like a trough and heat water that way with hot rocks. So there's several methods that you can use with bamboo. The limitations is you're limited on how many times you can heat it externally, and you're limited to location. It's not going to be available everywhere in the world, so you'd have to be in an area that has bamboo. So wooden containers. We're really looking for soft woods, because most of your hardwoods will crack, or roots of like a cottonwood tree or a willow tree. The cottonwood tree, for most people in bushcrafting or survival, they really like the dried root of a cottonwood tree, because it's easy to carve and you can make some pretty cool utensils and good containers out of it quickly without having to damage your knife. Yes, you can burn into them, but it's much easier to carve those because they're so soft and pliable, and they tend not to crack. So advantages, wooden containers, almost, not all situations, you can find wood to use. So even in desert environments, you can find some sort of wooden plant material that can be carved. But like I said, not all situations are you going to have wooden containers. That is one of the limitations. But in most situations, you can find some sort of wood source. It can be used in conjunction with hot rocks to heat it internally. It is portable. It's something that you can move around with, and something that should last you quite a while. You got to be careful on the types of woods that you use. No conifers, no cedars, no pine, anything that may have a toxic sap you don't want to use. You want to know, you would use woods that you could smoke meat with. So like oak and maple, sycamore, willow's good. So nothing that's toxic, or no wood that you couldn't identify, because you don't want to run the risk of cooking out the toxic sap and then ingesting that. So wooden containers often are carved, and I should also clarify, are burned, but there's no external heating, because you would obviously burn up the wooden container. So here's an example of me talking really about wooden containers and how to burn it in. This one I don't like to use too much in class because there's always the risk that somebody could get an ember in their eye, or somebody could walk upwind of somebody else, move that container around and have an ember drift on somebody else. So I normally have the class make ground containers or carve their containers. Yes, there's a risk of getting cut when you make a wooden container and carving it by hand, but burning, you're more likely to get injured burning a container in because of how close you have to get if you don't have some sort of device like a bellows to blow the coals in. And even then you run the risk of getting burned. And sometimes the heat will cause wood to crack. Even it doesn't look cracked, and then as you heat it up, maybe it wasn't thoroughly dried, and then you dry it too fast and it cracks. That's another disadvantage of burning in a wooden container. But I mention it because a lot of bushcrafters use that method to save their knife. Low earthenware, ceramic ware. We're really looking at low earthenware. We're not going to get, I mean, you can get the heat that you need for ceramic, but low earthenware has really more uses for us because we can heat it externally. Ceramic, if you heat it externally, you can put it in thermal shock. It'll explode. I don't know if you've ever put a ceramic plate on your stove by accident and accidentally turned on the stove and it exploded. Same thing can happen with ceramic ware in the wild. So low earthenware can hold external heating enough to boil. You wouldn't want to leave it on there too long, but it can be boiled externally or heated externally, and it's portable. Limitations, it's fragile. And the main limitation is time consuming to make. You got to have the right resources. It requires fire. You can fire it in the wild by just digging a fire pit. You don't have to have a kiln, but you're looking at easily 2 days of work. Because at a minimum, you'd want the clay to dry at least 24 hours, preferably more. But let's say at a bare minimum, on what I've had succeed, 24 hours of drying, and then another 24 hours of firing in a fire pit, and it is a pain. So what you're looking at is once it's dry, so that's 1 day, then you put it into the ground. You build a fire first and heat it up around the fire because you don't want it to go in thermal shock. And then you put it in the coals and then build a fire really quickly on it so no wind gets to it. Anyway, you can watch the videos, see how it works. But that's another full day, and then you got to let it cool overnight. So you're looking at easily 2 days of work, and in a perfect environment, we really only have 3 days without water. This is not something for short-term survival. This means that you're going to be there for a while, you're going to be there for a long time, and you want some low earthenware to use, and you got time to make it, and you already have other containers for your water. This would be something where you're trying to design something out of clay that's specific to your needs, either for food storage. You can make a low earthenware methods of distilling water. So yes, it has some uses, but it's more long-term survival, and that's the reason I mentioned it in the earlier slides. Here's some videos about it just in case you're into it, or maybe you're taking an art class. You can compare if you're already taking a ceramics class onto how current modern methods of making pottery versus primitive methods, and this would be the most primitive. So this one just kind of talks about how to make the clay and stuff, and then this one actually goes into the methods of the process of making the pottery. So wood ash. Now this one is used, but sparingly. You've got to really experiment and get the right mixture. So advantages can be heated externally, it's portable. Limitations, it's fragile, it breaks, requires fire to make your wood ash. It requires water to mix the wood ash. It requires the correct mixing of clay and wood ash. And there's always the risk of higher amounts of potassium hydroxide or lye in your mixture. So there's been a lot of research on this. Most research will support the claim that different types of wood produce different amounts of potassium hydroxide, which is caustic. You don't want to get this stuff in your eye. You really got to soak the wood ash in water for a long period of time. But there's a lot of debate on, should you use this with any kind of food product? Should you use this with any kind of water because it is so alkaline? So this is an iffy one. I just put it out there because there are some videos on it. I would put this into the iffy category, meaning that you need to experiment until further research definitively supports the safety of using wood ash. I wouldn't use it right away. This would be a last ditch effort. I have no other choice. I would use wood ash, but there needs to be more experimentation with this one. Kind of new. It's not new. I mean, wood ash has been around for a long time for other uses, but with the varying amounts of potassium hydroxide, I would be a little leery of it. All right, additional uses for wood ash. So I know they do this in Costa Rica, and they do it in Mexico as well. In fact, if you go to like H-E-B or a grocery store and you look, a lot of the cornmeal, the masa that you'll get, has been through this process, because it can get rid of mycotoxins, but it also brings out the nutritional content in the corn. I know that the Blue Zone Diet book talks a lot about this. Like, they looked at these centenarians across the world, and all these blue zones, meaning they had higher than average amounts of people making it past 100 or to 100 years of age. And the area that they looked at in Costa Rica, they looked at their diet, and they thought a lot had to do with this wood ash bringing out the nutritional content in the corn, because they had a higher than average population getting to 100, and this was a large part of their diet. Almost everything they made, all their tortillas, came from this masa. Anyway, it's also made, the potassium hydroxide is extracted from the wood ash and concentrated, so it's reduced. So you soak the wood ash in water, the potassium hydroxide comes off in the water, then you strain off the water without the wood ash anymore, and then you cook it down. And anyway, there's a whole process of mixing this with fat, and you can come out with a soap. So it's also been used as a ceramic glaze, so you can combine these two with primitive pottery if you have the ability to glaze your pottery and refire them. Kind of need a kiln for that. It's kind of hard to do in a pit. Yes, you can make ceramics in a pit, but to actually get a glaze and reheat it without it exploding is pretty tough. Wood ash is also used as an organic fertilizer. Native Americans used to burn off crops. Aboriginals used to do the same thing, and then they would go out, harvest animals that were killed in that, but they also did it to enrich the soil and enrich their crops, to put more nutrients back in the soil. So, containers and food preservation. So we're getting into food preservation in the next module. Containers can be used for dry storage, like if we had nuts that we needed to keep dry, or potatoes or something like that that we needed in a cool, dry location. Containers can be used to do that. They can be used for canning. Now we're getting into this modern form of food storage. Canning as we know it today would be very difficult to do with primitive ceramics. You're just not going to get the seal that you need. Pickling can be done, and fermenting, lactic acid, well, both methods of fermentation can be done in ceramic and low earthenware containers. But here's the deal. With low earthenware containers, they're porous. They will soak up fluids from whatever you're fermenting. They can only be used once, because after you've used them, bacteria can form in those pockets. And then you run the risk of getting bacterial contamination in your food if you try to reuse low earthenware containers. So we're mainly concerned about botulism. But yes, lactic acid fermentation can be made in ceramic pots. If you look how they do it in Korea, traditionally, they take these ceramic pots and then they put all the mixture in, all the cabbage and everything to make kimchi, fill it all the way up to the top. They put their acid in there to kind of speed up the process, and then they let it ferment. And then they let it ferment for a long period of time. And then to seal the lid, often they'll just bury it underneath the ground. So they'll put the lid on, just throw dirt over it, and that makes an airtight seal. And they let it ferment. So I encourage you to look up how kimchi is traditionally made. And that'll give you a good idea how you could do this in a primitive setting, but you got to know what to kind of mix it with to get that lactic acid fermentation to kick off. You can easily do alcoholic fermentation in a ceramic jar. So you would heat it up to kill off any kind of bacteria, and then after it's heated, you would put your mix in. Hopefully you have some natural yeast already mixed in with the fruit. Let them ferment for a while. After 3 or 4 days at 80 some odd degrees, it's probably going to stop fermenting. Then you strain it off from there and leave the residual sludge behind. And then you go through another 3-week process of secondary fermentation. So that going from primary fermentation from that first 3 to 4 days, and then straining off the fluid portion and leaving behind all the pulp is called racking. And there's several ways to do it. But the simplest method is just to pour it off instead of siphoning it off. And then that other 3 weeks allows that yeast to continue to break down any remaining sugars in the fruit mixture. And then you come out with a wine. You can do this with beer. You can also make a sourdough bread as well by using a yeast fermentation. So if you've ever heard of somebody that has a family starter for sourdough bread, that's what they're doing. The easiest way to do that in a primitive way is to take raisins, put them in distilled water in a quart jar, shake them once or twice a day just so no mold builds up. Leave a little vent area at the top and don't completely seal the jar. Let it be able to burp itself. And then do that for 6 or 7 days. It'll get real fizzy. All this carbon dioxide will build up. And then that can be dumped straight in, even with the raisins. And if you don't want the raisins in your bread, then you strain off just the water. Put that in with some flour and you can create a starter dough. Anyway. So the skill is to create a container. You can carve one, you can burn one. I would prefer you to carve it if you're going to do one or the other. The easiest method to do this is to dig a hole and line it with clay, or if you don't have clay, line it with a rain jacket. I did that in the video. Something that is non-porous, something that you could find washed up on a beach would work. If you have access to bamboo, you could use that as well. If you use wood, make sure it's non-toxic. So we're looking at willow. Yes, willow has salicylic acid. That's the active ingredient in aspirin, but it's not enough to hurt you. Sycamore, oak, maple, walnut, pecan, hickory, mesquite, any of those could be used. But avoid conifers such as pine, redwood, fir, spruce, cypress, cedars. All of those have resinous saps, especially pine. You don't want to get any turpin, which is what turpentine's made from, out of the pine. So you wouldn't want to use any of those as your containers. And that is it for the video.